It's time for another Algebra 2 Regents quick question walkthrough. I'm actually adding this video in prior to the one I already recorded on this. I think it's important for this question to highlight a few things that happen in the Regents sometimes. This is an actual Regents question with the exception of the Little Bo Peep theme. I changed the names, but it's been a question that's been asked. And I think what's important is that sometimes in formulas we get stuck on the variables that are in formulas. And while it's very important to have consistency in mathematics, occasionally you're going to have questions that the variables are going to represent different things. And for example, we first learned that there's f of x for a function, but at times we call it h of x or p of x or a of x or a of y or a of t or something like that. We end up changing it sometimes, but the principle of the mathematical equation is still the same. This question is a case of that, and I wanted to point it out because, as I said, it was an actual 6-point Regents question. It may appear again, and I think it's important to kind of look at it for a second. So the question is really asking our usual compound interest formula. We know that formula to be the normally a of t equals p times 1 plus r over n times nt, where they're represented in the following. A represents our future value. P ends up being our principal or present value. R is our rate expressed as a decimal. That t is our time in years. And that our n is normally the number of compounding periods per year. We're pretty familiar with that, and looking at this question, I can see that it is investment, that she does seem to want a future value, that we do have a principal or present value to it. I can also see that I do have a rate, two of them. Obviously, I'm exploring two different investment options, but they're clearly rates. We're clearly talking about time because it goes through talking about years, and I'm going to want to calculate that. There's definitely a compounded annually, and the compounded annually makes me think if it said compounded continuously, it was going to be my PERT formula, compounded annually, quarterly, daily, monthly, things like that are alerting me to my compound interest formula. Where the question gets a little bit confusing is they're asking me to find this in, I'm just going to use a different color here. They're asking me to calculate the value of each account after n years. Normally, I would think of years in terms of t, and I would think of n as in terms of my number of compounding periods per year. So what ends up happening is my t value really becomes an n, and my compounding, and when I'm doing the quarterly and the annually, I have to sort of put those numbers in the placeholder that normally would be my n. However, this time the n I'm solving for is essentially my t. So that's where it's a little bit confusing, but this is an actual Regents question that was used. That's why I think it's important to explore it and be familiar with it and not get hung up all the time on the variables. So again, we're going to continue on with solving this, and I just wanted to add this little precursor video to kind of explain a few things. Okay, let's try it. It's time for another Algebra 2 Regents quick question walkthrough. This one says Little Bo Peep has $4,000 to invest in a wool sweater company. She's considering two different investment options. Option A will pay her 3.4% compounded annually. Option B will pay her 3.5% compounded quarterly. Write a function of option A and option B that calculates the value of each account after n years. I'm going to use pink for option A. And option A, it says, is compounded annually. So I'm going to write my function as A equals 4,000 times 1 plus 0.034 over 1 times n times 1. I've got those values because 3.4% becomes 0.034 in decimal form. Annually means that it's going to be once a year. Next, I'm going to do option B. Option B will pay her 3.5% compounded quarterly. So option B, I'm going to write as 4,000 times 1 plus 0.035 over 4 times to the 4th. Got those because of the 3.5% is going to give me 0.035, and quarterly would mean 4. I finished the first part of the question, which was asking me to write the function. Bo Peep plans to use the money to expand her farm in 5 years. Determine how much more money option B will earn her than option A to the nearest cent. In 5 years, option A is going to earn Bo Peep 4,000 times the quantity 1 plus 0.034 over 1 to the 5 times 1 power. Simplifying that, I get 4,000 times 1.034 to the 5th power, and putting that in my calculator, that gives me 4,727.839068. Meanwhile, if she sticks with option B, it would get her 4,000 times 1 plus 0.035 divided by 4 to the 5 times 4 power. Simplifying that a little bit more, I get 4,000 times 1.00875 to the 20th power, and then putting that into my calculator, I get 4,761 $35.9197. Part B of the question, that was asking me how much more money is option B going to earn than option A, which means that I'm going to need to subtract the one from the other. So subtracting, doing B minus A, I get $4,761, $35.9197 minus $4,727.839068, which gives me $33.52012942. But it's asked me to the nearest cent, which means she's going to earn $33.52 more by keeping her money in option B. The last part of the question is ask me how long it's going to take her to double her investment to the nearest tenth of a year. So first I'm going to try for option A. Option A, for her to double her investment, it would be at $8,000 times 1.034, and solving for n, I got dividing 4,000 on both sides, which gives me 2 equals 1.034 to the n. In order to get that variable out of the exponent, I'm going to need to take log of both sides. I get the log of 2 equals the log of 1.034 to the n power. Probably do that to make it more clear. Using the properties of logarithms, I'm going to bring that n down to the front, so I have n log of 1.034. I'm going to divide both sides by the log of 1.034 to get my final answer for how long it will take. And n is going to equal, my answer is 20.731 years. But the answer is to the 10th of a year, so 20.7 years for option A. For option B, doubling her investment, rewrite this as 1 plus 0.035 4 to the 4n. Continuing to simplify a little bit, I'm going to simplify again the part in the parentheses. 1.00875 to the 4n. Divide by 4,000. Divide by 4,000. I get 2 equals 1.00875 to the 4n. Take the logarithm of both sides. Next thing I'm going to want to do is I'm going to want to bring the exponent down to get log of 2 equals 4n times the log of 1.00875. Then I'm going to divide both sides by 4 times the log of 1.00875. That will free up everything and just on that side and just have the n remaining. For the log of 1.00875. Putting that into my calculator, for n I get option B will only be 19.89 years, or to the nearest 10th of the year, 19.9 years. So definitely a faster way to double investment. And I'm done with the question.